All right, hello, let's get this series started again, this time for the 2024 calculator test. We're going to be going over Invitational A. My name is Carson Winter, and hopefully I'll be able to guide you through all the word and geometry problems on the test. And I assume you know how to do the punch problems. You put them in the calculator. Let's go. Starting from the beginning. Starting with This test had some baby problems for the beginning. Was 4710 divided by 8.9 or 9.82. Put in the calculator, get your answer, 3 SDs. Similar for number 7 was the cube root of the result of that minus that. Just plug it into your calculator and you get negative 2.41. A printer prints one page every 6 seconds. How many pages can be printed in 4 minutes? Well, in this case, you got to figure out how many seconds have passed. So 4 times 60, 240 seconds have passed. And if one page is printed every 6 seconds, you divide by 6, multiply it by 1, and you get 40 pages being printed. Okay, circle and circumference. Circumference of a circle is equivalent to 2 pi r. So x, or I guess r in this case would make more sense. R times 2 times pi is equals 680. Put that in EQ solver, or just, divide that stuff by 680. And you get 108. Number 10, area of a trapezoid, uh, average of the two bases. So add those together, divide them by 2, multiply by your height, that's unknown, and you get your area. Put that in EQ solver, and you'll get 47.6. 16, it's really simple. You just add up all the stuff. I guess they're trying to make sure you know that you have to go to the nearest cent on dollar sign problems instead of 3 SDs like normal. But in any case, that's not a difficult problem at all, and you should be able to do that. 17, 2 million car accidents each year. There are this many licensed drivers. There are 1.79 cars involved in a crash, and no drivers are involved in more than one crash. How many fractions are involved in car crashes annually? Well, in this case, you have to figure out the total number of cars involved in a car crash per year. So 2 million times 1.79 cars involved in accidents each year. And then you have to divide it by the total number of cars. So 232.8 million. And then multiply by 100 to turn it into a percent, and you get 1.54%. 18. Half of the U.S. 332 million population drinks 12 ounces of coffee daily. How many tanker trucks would this represent if the tanker truck capacity is 3,500 gallons? Okay, first off, we got to convert ounces to gallons. So in this case, you would divide by 128. If you don't know that, you can go to side tools, press apps, scroll up until you see side tools. Then you go to volume. And then you can plug in 12 ounces and convert to gallons. And you'll see that 12 ounces is equivalent to 0.09375 gallons. So if you do that, now they have how many gallons per cup. You multiply it by the number, or by the US population. Since it's half, you divide by 2. And then you divide by the 7,500 gallons in a tanker truck to find out that it would be represented by 2,080 tanker trucks, which is a lot. 19, this is a pretty simple one. They want this sign, they want this side, you have the hypotenuse, you have this angle. Definition of cosine, 814 times cosine of 58.5 will get you this side right here. 20, another very basic Pythagorean theorem. A squared plus b squared equals c squared, so square root of the two sides squared. You get 1.24. A spherical balloon 15 inches in diameter is inflated at constant volume rate. If it was 6 inches in diameter after 2 seconds, what's the total time required to fill the balloon? Well, since it's filling at a constant volume, volume is based on is proportional, I suppose, to the diameter cubed. So you have to divide the diameters. So to get 2.5 times the diameter, you have to have 2.5 power to 3 times the volume, if that makes sense. It's a scale problem. And then because that took 2 seconds, you have to multiply that value by 2, and you get 31.3 seconds. William's parents measure his growth annually. When he was 5 years old, his height was that. A year later, his height increased to that. How tall was Liam on his birthday? So in this case, you got to add up all this stuff, convert it all to feet. 3 feet plus this amount of inches, convert to feet, plus the height increase, convert to feet. And since you're adding, you keep the highest SD, so 4 SDs here. So you get 3.772 feet. Surface area of a sphere is increased by 4%. What's the percent change in volume? Well, surface area of a sphere is based on r squared, and volume is based on r cubed. So you have to take that difference, square root it to get r, and then cube it to get volume. That's simplified all by 1.04 power to 3 over 2. And then you have to subtract 1 to find the change, and multiply by 100 to make it a percent. Okay, surface area of rectangular solid. You got to find the area of all these rectangles. So this side times that side, plus this side, unknown side, times that side, and same with 503 times your unknown. And that will show this one right here, or this rectangle right here, this rectangle right here, and the one up here, I suppose. And that's only half of the entire rectangular solid, so you can counteract that by dividing the total surface area by 2. You can also just multiply all these by 2 if you want. It's just quicker to do it this way. Regardless of what you do, you'll get a length of 1,180. Okay, okay, now we have the volume of a square pyramid. Well, a pyramid is the base area here times the height over 3. So the square area on the bottom is 0.0101 squared. This height is going to be cotangent of 29.5 times this length right here, which is going to be 0.10101, etc., divided by 2. And I believe that should get you like, what would it be, like 0.8 or something? Maybe it was higher. Let me check. No, it's going to be about the same thing, basically. So yeah, you multiply it by that height, and you divide by that 3 because it's a pyramid, and you get 3.54 times 10 power to negative 7 as your volume. 36, New Year's resolution. Charlie went on a diet. Her starting weight was that. She averaged 6 pounds lost per week. What's percent decrease in her weight on that date? Well, we got to figure out how many weeks have passed. So the entirety of January, the entirety of February, and now 6 days of March. And since it ends in a 3, which is not divisible by 4, it is not a leap year. So February has 28 days in it. Because of that, you have to subtract 3 pounds lost per week, add up all the days, divide the days by 7, convert to weeks. And then that will get you her new pound, her new weight. You divide by 163 and subtract that from 1 to find the percent decrease. And then I guess I forgot to write, but you have to multiply by 100 to get a percent. So you get 17.1%. 90% of that decay isn't that long. What is its half-life? Well, we got to figure out how many instances of the element halving have happened for 90% of it to decay. So that is log base 0.5 of 0.1. You'll get like 3.2, I believe. And then once you have that, that represents the amount of times it is halved, basically. So once that happens, so that happens, you have to divide the total amount of time it took, divide by how many times it's halved to find how long it takes to halve. And you get 5.26 years. 38 number 38. Bulldozer scoops 2 cubic yards of dirt because the dirt is muddy. 15% of the dirt in the first scoop permanently adheres to it, and same thing for 15% of each. Basically, each scoop is 85% of the previous one, which is a geometric series. So for a geometric series, to find the sum of them, you take the first value, which is the first amount of dirt bulldozed, so 2 times 0.85, and then you divide it by the 1 minus the common ratio, which in this case would be, since 15% is going away, 0.85% is remaining, or 0.85 is remaining. 1 minus 0.85 divided by your original value, and you get 11.3 scoops or bulldozers filled with mud. 39. You need to find the radius of an inscribed circle. You can use the triangle pair circ. Just use Pythagorean theorem to find this side. You can also use the actual equation for the inscribed radius of a right triangle. Out of the two sides, subtract the hypotenuse, and divide by 2. Regardless of the method, you will get an inside radius of 2.26. 40. Scaling triangles. In this case, you need to use SSS program to figure out this side right here. You get 72.33 degrees. Then once you have that, you can use side, angle, side to find this remaining side right here. And this side is 4.25 because that's given. Then once you do that, you get 5.71 as your length. Okay, a box can hold 850 rocks that are 0.73 inches long. How many 0.03 inch long grains of sand could be poured into an empty box? Well, each grain of sand is 21 times smaller in each dimension. So since this box is based in volume, you have to cube that difference. So you can fit 0.73 divided by 0.03 power to 3 times as many grains of sand as rocks. And then you multiply by the 850 rocks you could originally store, and you get 1.22 times 10 power to 7 grains of sand. 47, you got to use stat edit and then use a linear regression. Go to stat, edit, put in all the data points they give you. If you want to simplify, you can put the years and then remove the million from all the y values and then just set y1 equal to 30. Or you can actually write 8.95 million, all of that. And then you need to estimate the year, which the population becomes 30 million. Once you have all the data input, it go to calc or stat, calc, linear regression, store regression in y1, and then you will go to EQ solver and figure out the value in which y is 30 million, or 30 if you cut out the million like I would do. And then you'll get a value of 2043. Since it's a little greater than that, it's in the middle of it. That means it happens on that year. So you do indeed round down. Okay, for what non-zero negative value of p does that equal p powered 4? Put that in EQ solver. Not much to say. Make sure you're in radians. Move on. Okay, we need to find this unknown height, and we know that the surface area of the hemisphere is the same as the surface area of the cone. So in this case, surface area of the hemisphere. Well, in this case, a surface area of a sphere is r squared times 4 pi. Since it's half of that, 2 times 2 pi instead. And that's equal to the lateral surface area of this cone. So for lateral surface area, you got to find this length right here. I guess first I'll go over this. surface area of the sphere. And then you need to figure out this side length right here. So square root of your a squared plus your unknown height, which is your unknown minus 99.4 squared. And that entire thing will get you this side right here. Then you multiply it by the circumference, so 2 pi r. And then you divide by 2, because that's just what the equation says. And once you do that, you'll get a unknown value of 272. Okay, 50 is a bit of a long one. It's really more annoying though than it is hard. First off, you need to add up the entire surface area as if this encavement right here does not exist. So area of these two equilateral triangles on the front and back. So side squared times square root of 3 over 4. There are 2 of them, so multiply by 2. And then you have to find out the area of all these rectangles. 0.716 times 0.19 times 3. And then once you have that, you subtract it by the amount taken away by this circle on both sides. So diameter over 2 squared times pi, and then times 2 because it happens on both sides. And then you also have new surface area added. You have this encavement right here, so which is equivalent to the diameter times this 1.19 length. So x pi times 0.19, and all of that is equal to 0.906. Solve for x, you'll get a value of like either 0.15, but you might get a value of like 0.15, but since d has to be greater than 0.2, you should do a higher guess in EQ solver. And if you do that properly, you should get 2.32. Okay, 56. The curve is integrated from 0 to x1, where this is the bounds of x. If the area is equal to 0, what is non-zero x? Consider the area below the x-axis to be negative. Well, okay, so, and this isn't too complicated. You just got to EQ solver it. You got to figure out what upper bound, so integral from 0 to an unknown z of x cosine of x is equal to 0. And then you EQ solver for z. And then the calculator may take a bit. Make sure to put a guess in between this range, preferably in the middle, like pi. And if you do that properly, you'll get 2.33. Okay, 57, this is your straight line distance problem you see every so often. So first off, 5 minutes, this dude is traveling south to Muleshul, 28 miles away, and 5 minutes later, Mike is leaving Muleshul and traveling east at 55 miles per hour. So it's forming a right triangle, basically. Okay, so I guess so easiest way to explain that is, well, first we need to figure out how far away Frida is from Muleshul before Mike starts leaving. So 28 miles minus their speed times their time, and you get that is your new distance. Oops, I forgot to modify that here. So yeah, with the closest straight line approach is going to be when the derivative of the approach is equal to 0, because the approach is going to look like this. So you want this minimum point right here. To do that, you'll want to put this entire equation into y1 so you can plug the x back in. But basically, you need the derivative of the Pythagorean theorem of the height, which is going to be the total distance to Muleshul, minus 70 times your time squared, plus the distance traveled to the east, so 55 times your time squared. And if you do that, figure out when it's equal to 0, and then plug your found time back into this equation right here, you'll get a value of 13.7 miles. 58, calculate the product of the determinants of these two matrices. Well, just find the determinants. This times -3 times 9 minus 14 times 7 and 4 times 17 minus 2 times negative 12. Multiply those together, you get negative 11,500. Okay, 59, solve the revolution. You're going to want to use our auxiliary program for this. You have your bounds. Your bounds are x equals 0 and x equals 2. Make sure to put this equation into y1 and have y equals 0 in y2, because that's your lower bound. And then once you have that, you want to put in your line of revolution as negative 5, and then look for the y equals. And if you do that, you'll get 343. And then identical equilateral triangles and circles. You need to figure out this side right here. Well, to do that, that's the radius of the circle minus this unknown side right here. This angle right here is 60 degrees because it's an equilateral triangle. So 1 over tangent of 60 times this radius right here will get you this side, as you can see here. And then subtract the entire radius from that to get your unknown side right here. Okay, 61. Phyllis drives at 55 miles per hour from Hondo to Brenham. How fast should she travel back to Hondo if she wants to average 62 miles per hour for the entire trip? The formula for average speed is equivalent to distance over speed plus distance over speed is equal to total distance over average speed. So you need to figure out what speed she traveled on the first day. She traveled a distance of two trips, I suppose, would be the best way to put it. You do that, you get an x value of 71.0 miles per hour. 62, what is this underflow problem right here? You'll, like all 62s, you'll use our OFUNC-F problem or program. So you use underflow, you use the base, and then you use type in the exponent right here, and you'll get 8.15 times 10 power to negative 25025. 63, a diver runs off a 10-meter high platform directly over the pool's edge. What is the diver's running velocity if they splash into the pool 4 meters from the pool's edge? This is the entire reason. This is the only time we've seen them use meters. I have no idea why they use meters, but they did. So now our kinematics program has a meters in it. So kinematics meters, 2D. You're given x, it's change in x, you're changing y, and you're indirectly given the angle of jump. So they splash into the water 4 meters away. They go down 10 meters to splash into the water, and they are running horizontally off the platform, so your angle is 0. And then you'll get the velocity in meters per second, but we don't want meters per second, we want miles per hour. So convert this to feet per second, so times 3.2808. And then to convert from miles to miles per hour, divide by 22, multiply by 15, and you will get 6.27 miles per hour. 64, square and identical segments. Okay, in this case, you need to figure out this R value. This is pretty simple. It's an isosceles triangle. So this side right here is going to be equivalent to this side divided by square root of 2 is equivalent to your R. Then once you have that, you have to do circle minus triangle to find the hatched area. So R squared times pi over 4 would get you this entire thing right here. And then you multiply it by 2 because it's dual-sided. And then that's subtracted by the triangle, which is, since it's a right angle, it's R squared over 2. And then there's 2, and then it's dual-sided as well. So if you do that, you'll get a hatched area of 4.6 times 10 power to negative 3. Okay, 65, square and quarter circle. First, you need to figure out the length of this square right here. So since you know the areas are equal, You know the quarter circle, so radius squared times pi over 4 is the area of your quarter circle. And that's equivalent to your side squared. And then once you have that, you can use Pythagorean theorem to figure out this side. X squared plus 491 minus x all squared, and you get 445. All right, that's the entire test. I was able to finish this pretty quickly because this Invitational A doesn't have too many difficult problems. Aside from like that straight line distance one, you should be able to answer all the problems on here given enough time and practice. All right, see you later on Invitational B.